From the Great Pyramid of Giza to Burj Khalifa, humanity has outdone itself in construction. Some of these structures' sheer size, architecture, and fine details are indeed something to behold. While these structures reflect the genius in human beings and the capabilities nature has bestowed upon them, there are some structures that compel us to think quite the contrary. It makes one wonder what the designers even thought while constructing these structures. While there are tons of buildings and other structures that depict how stupid human beings can be, we have compiled some of the most insane construction mistakes in the world. Perhaps calling them a mistake is also an understatement. Why, you may ask? Well, let's look at them yourself in this video. Number 4. The Leaning Tower of Pisa. We have all seen the videos and the images of the Leaning Tower of Pisa in Italy. Some may even have visited it in person. While it has become a popular tourist attraction, it certainly was not the intention of its builders. The tower was supposed to be the third and final structure of Pisa's cathedral and serve as the bell tower for the complex. Construction on the tower started in 1173 to erect a 185 feet high structure made of white marble. By the time 3 out of 8 stories were completed, the faults in the foundation started to become apparent. The foundation was not strong enough to bear the weight of the structure, a rookie mistake. The mistake was identified, but right about then, a war broke out between Italian city-states, leading to the halting of construction for about a century. It was a blessing in disguise for the Tower of Pisa, as the break allowed its foundation to settle, which otherwise would have resulted in an early collapse. As the construction began, the chief engineer Giovanni di Simone tried to compensate for the lean by adding slightly taller stories on the short side. This proved to be another mistake, as extra masonry caused the tower to sink in even further. Since it was such an essential piece in Pisa's cathedral, several engineers joined heads to discover a solution, which delayed the construction, but it was ultimately completed in the 14th century. The tower's interior was lined with spiral staircases comprising 294 steps leading to the bell chamber. About 7 bells were installed in the next century, with the heaviest weight of about 8,000 pounds. It was soon observed that the bell's movement was worsening the tower's lean. Thus, it was silenced in the 20th century. Several solutions were proposed, and some were even implemented to correct the lean, but nothing worked, and the tower kept subsiding at the rate of 0.05 inches per year. In 1990, the tower finally closed, the visitors fearing a collapse. Engineers again joined heads to discover a solution and finally found one by 2008. Now the tower is expected to remain stable for at least 200 years. While it has been corrected now, it shows how some fundamental mistakes in construction can lead to such a waste of time and resources. Number 3. The Millennium Bridge. Next is the Millennium Bridge, a pedestrian bridge in London designed to become a benchmark of modern construction and complement the surrounding structures with a unique and sleek design. A competition was organized to develop a design for the bridge in 1996 by Southwark Council and REBA Competition. It was awarded to Arup Group, Foster and Partners, and Sir Anthony Caro because of their unique design that improved the view despite the height restriction by using a supporting cable below the deck level. The bridge had 2 river piers and 3 main sections with a total length of about 325 meters and an aluminum deck about 4 meters wide. 8 suspension cables were tensioned to pull with a force of 2,000 tons against each pier to provide enough support to withstand about 5,000 people at any given time. Everything looked on paper, but as soon as the bridge opened, it became clear that something was wrong with the design. The bridge started to sway on its sides as people started walking, causing fear in the pedestrian. Right after a couple of days of its inauguration, the bridge was closed and engineers began to diagnose the problem. Turns out the design of the bridge was a little too flexible, and the frequency of the bridge matched the walking pace of pedestrians, leading to a phenomenon called synchronous lateral excitation. In English, it means an augmented side movement when people start walking on the bridge. Since the view of the bridge was one of the primary concerns, the traditional solutions were not helpful. Engineers controlled the resonance by retrofitting 37 viscous fluid dampers to dissipate energy. The correction work took about a year and cost about £5 million. Number 2. Citibank Center. You are wrong if you think only Europeans make such lousy construction mistakes, because our next mistake takes us to Citibank Center in New York City. It was designed to be a 59-story skyscraper to serve as headquarters for First National Citibank. The challenge was to separate St. Peter's Lutheran Church, which was supposed to be erected on the site's northwest corner. Engineers took up the challenge and designed 4 stilts right underneath the 4 edges of the tower. However, the agreement with Church prevented that. Bill LeMessurier proposed to use inverted chevrons as load-bearing braces stacked above the stilts inside the building's face to work around the agreement. According to the design, the braces should distribute the tension loads the wind creates from the upper stories. The new design warranted on-site fabrication of section and assembly that required 5 joints in each brace. Initially, welded joints were used, but another engineer proposed switching them with bolted joints to save cost, something which was apparently not known to the chief engineer. During wind load calculation, only the wind that blew perpendicular to the building was calculated, as it was the only requirement by the New York City Building Code. Typically, these winds are the worst case for the structures, and those that can handle them can cope with the wind at all speeds from all other angles. But this was not a typical building, and engineers did not calculate the effects of diagonally oriented quartering winds, which would affect the structure the most because of its unique design. Princeton University student Dane Hartley pointed out the mistake in the design in his thesis. Luckily, the designers quickly spoke with the student and understood the flaw in the calculations. Reinforcement was carried out at night while workers used the buildings during the day to rectify the mistake. The reinforcement work was kept hidden from the workers in the building. Repairs were completed by 1978, but the scandal remained secret till 1995 when a hurricane threatened NYC. Although the hurricane was diverted, it opened a Pandora's box, requiring another video for explanation. Number 1. Hyatt Regency Walkway Collapse. The last mistake for this video takes us to Kansas City, where Hyatt Regency Hotel met with a tragic disaster in 1981 when 2 walkways collapsed and killed 114 people and left more than 200 people seriously injured. The investigation of the incident revealed the mistake was rather basic, but was overlooked by the engineers. As part of the design, steel rods suspended walkways from ceilings. Unfortunately, the rods had flawed designs as engineers used 2 rods instead of a single piece, significantly reducing the strength of the connection. Furthermore, the welding of rods was also subpar, which weakened the connection even further. In simple terms, a case of criminal negligence went unnoticed until the connection collapsed when subjected to a large crowd. The walkway collapsed, leading to the loss of precious lives and leaving 100 others injured. It was followed by a legal investigation by the Missouri Board of Architects, professional engineers, and land surveyors that found the engineers at Jack D. Gillum and Associates who approved the final drawing of the project responsible for gross negligence, misconduct, and malpractice of engineering. While the company was acquitted of all charges, its license was revoked in Missouri, Kansas, and Texas. The company also lost its membership in the American Society of Civil Engineers. Furthermore, over 300 lawsuits were filed against the company that sought compensation worth $3 billion, and about $140 million from them were awarded to the family of victims and survivors. The collapse remains the deadliest non-deliberate structure failure within the U.S., which led to several upgradation and improvement in the curriculum of engineering ethics. That is all for this video. Let us know your thoughts in the comment section and whether we should make a sequel. Stay connected with the channel and do not forget to like, share, and subscribe. As always, we will see you at the next one.